Okay, logarithmic equations, part 2. Logarithmic equations, part 2. Okay, so you've seen these type, not the ones from yesterday, but from the very beginning, we did solve some logarithmic equations. I mean, they're going to hopefully be so easy for you now. But they were like this. Like if I tell you log 2x equals 4. Remember that? Yeah. And anybody remember how to look at this or how to do this one? Well, remember we want to what? We want to have, you're going to have only one logarithm here and a number on this side. Remember yesterday you had a logarithm equal to a logarithm. Remember that? Make sure you know how to tell those apart. But this one you're just going to have one logarithm on one side and then you're going to have like a number on the other. We'd learned these already, right? We have learned to do what? Change this to exponential form. This one's an easy one, right? This is going to be what? 2 to the power of 4 is equal to x. And then your job is to solve for the variable. Make sure the variable is alone. Oh, look, it's already alone. Oh, then the answer is whatever 2 to the power of 4 is. 2 to the power of 4 is not 8. 2 to the power of 4 is 2 times 2 times 2 times 2 is 16, yeah? Yeah. And we've learned those. Okay, that's not new. What if you have something like log 2m equals negative 3? What if it's a negative number? Can you handle that? Yeah, because we learned that also. Okay, so again, you're going to look at this counterclockwise, right? You got to have one logarithm on one side and a number on the other side. That was the way we've seen this in the past, and you remember, you don't want to work in logarithmic form. We change it to exponential form. Oh yeah, that's what we're doing. We're changing it to exponential form. This would be 2 to the power of negative 3 equals m. All right. What's going to happen here? Anybody remember that? You take it to the bottom. Remember, that's going to be 1 over 2 cubed, yeah? We don't do negative numbers. You got to make sure they're positive, and then so that drops to the bottom. Remember that stuff? Yeah. You're like, yeah. And then we even had some fancy looking ones, but you were able to handle it. Are we okay with that, with those first two? Okay, and then what if you had something like this? Last of these easy ones that you've learned already. What if you have log 6 3x minus 2 equals 0. Oh yeah. It's still this type of problem. It's still this same type of problem. Why? Because there's only one logarithm on one side and the number on this side. When it's one logarithm only and a number over here, which is what you're going to want to set up, these are the ones you do that counterclockwise business, yeah? Yeah. This is going to be 6 to the power of 0 equals 3x minus 2, yeah? Yeah, we've done those last semester. What's anything, or what's 6 to the power of 0? 1. You guys remember that deal? Oh, yeah. 1 is equal to 3x minus 2. That's going to be 3x equals, 3 equals what? 3x equals 3, right? Because this negative 2, when you move it to that side, it's going to be positive 2. I think you can handle that. Okay. You guys remember how we learned this already? Yeah, we learned this already. Okay, so now let me show you the ones you're going to do now. Ready? Okay, here's the new problems. These new logarithmic equations. Here it goes. Number 4. These are the ones for today for this section here. Talk to me about this. Now we're going to take everything we've learned, everything we've built up to understand up until today, and apply it. Oh my God. Hold on, I messed up. That's not right. I didn't copy it right. Sorry. Log 2 parentheses 2x plus log 2 and then another parentheses 2. That's where I messed up. Equals 3. Okay. Anything that has an equal sign, it's an equation. This is a logarithmic equation. Okay. Anybody have any ideas on this? Huh? Yeah, see, remember that? On these, well, where's the other one? Remember, I only want one logarithm on one side and a number over here. Do I want two logarithms? No. So what are we going to do? I like that. You said it. You got the word correct. Condense. Condense into one. Condense into one logarithm. I don't want two of them. I just want one. So everybody agree this is going to be what? Log 2. And what happens with a sum? Do they come up and I add these? No. Remember a sum going backwards? Going backwards is what? 2x times. Isn't it a multiplication? Remember sum, when you bring it back together, it's a multiplication? Yeah, huh? Equals 3. You guys agree with that? Are we good? This is not new. Okay, so really the problem is what? Log 2, what? You guys agree really that's what's going to happen? Sebastian, no? Yeah, right? If I have to multiply these, what's 2x times 2? Well, 4x. Now can we solve this? Yeah, now you solve that. How do you solve this? Well, they look like the ones we were doing earlier. Don't you do that counterclockwise business like this? Yeah? That's going to be 2 to the power of 3 equals 4x. 2 to the power of 3 is 8. 8 is equal to 4x. Oh, this one's going to give us a nice answer. Are you always going to get these nice answers? No, you'll get negative numbers, you'll get fractions. Okay, everybody see how it's just using and applying everything we've... Okay. Questions on this one? We're good? Okay, let's try another one. Number 5. What about log 3 9x plus 3 log 3 4 equals 0. Oh, sorry. Oh, shoot, what? Okay, what's going to happen first? See this number? What's going to have to happen to it? To the top, right? So it's going to be log 3 9x plus what? Log 3. Everybody agree this is going to be 4 cubed now? Because this 3 goes up. Yeah? Equals 0. And that's going to be, well, bringing it together now, it'll be log 3 what? 9x times whatever 4 cubed is equals 0. What the? Oh, there it is. And that's really going to be 9x times 4 to the power of 3 is 64, no? 64 times 9, I don't know what that is. 64 times 9, 60. I think it's, I don't know what it is, 144? Oh, 576, not even close. Okay. So what do I have? Oh, log 3, 576x, right? Because there's an x right there. Equals 0. That's what you want to get it to. 1 logarithm equal to, and then the number on this side. We're good? Then what? We change it to what? We don't want to solve anything ever in logarithmic form. We're going to change to exponential form. 3 to the power of 0 is equal to 576x. Yes, this is 1. 1 is equal to 576x. What's the answer? That's correct. Okay, 6. Ready for the next one? We're good? If not, remember, I'm going to put this up on the video. You guys can watch it again or watch it as many times as you need. The next one, number 6, log base 7 of 9x minus, oh yeah, 2 log, obviously 7, 6 equals 1. Well, this one's the one that's got to fix a little bit. So that's going to be log 7 of 9x minus, everybody agree it's going to be log 7 of what? 6 squared? Because the 2 goes up? Yeah. Equals 1. Oh, what? Equals 1. And minus? Uh-oh. Minus when it comes together is not multiplication. What's that? That's going to be log 7 of what? 9x. Oh, shoot. 9x over? 6 squared is 36, isn't it? I should put 6 squared, but I'm going to write this again. That looks bad. Log 7 of 9x over, you could put 6 squared, or I know 6 squared is 36 right there, equals what? Equals 1. But honestly, before I change it, can't you reduce here this 9 over 36? That can be reduced, right? So that's going to be really log 7 of, I get x over 4. Does everybody agree it reduces to x over 4 or 1 over 4? 9 goes into 9 once, 9 goes into 36 4 times. Equals 1. Oh, yeah. That's right. Okay. Now we change it to, or we, to solve it, we do counterclockwise. That's going to be what? 7 to the power of 1 is equal to x over 4. And 7 to the power of 1, 7 to the power of 1 is just 7, no? Anybody remember how to solve an equation like this where there's a fraction? Anybody know how to do that? Yeah, we don't want fractions, so we know how to do something to get rid of this. We can multiply by what? 4, right? But whatever you do to any term or any side, you got to do it to all terms on all sides. So if I multiply this by 4, I multiply this by 4. Answer is going to be what? X equals 28. Okay, last one. Very similar to this one. Log 6, so we're going to go quicker. Log 6, 8x minus 3. Log 6, 3 equals 2. This one's going to go up, so that's going to be log 6, 8x minus log 6, 3 cubed equals 2. Yeah, which we know 3 cubed is 27. Okay, so now bringing this together as a single logarithm. There's a minus there, though. That's going to be what? Log 6, 8x over? Over what? 27, right? 3 cubed, but we know that's 27. Equals 2. And can we reduce? No, we can't reduce the 8 and the 27, huh? No, damn. Okay, we can't reduce. All right, so now change it to exponential form. 6 to the power of 2 equals 8x over 27. Go ahead, solve that. Let's see what you get. We're going to get some big numbers here, huh? 6 to the power of 2 is not 12. 36 is equal to 8x over 27. Go ahead and get your answer. I'm going to write mine, okay? Okay, you're probably doing it the hard way, so just stop already. I'm going to show you what you want to do. Ready? Does everybody agree here we're going to have to multiply by 27? Multiply by 27, but don't. Ready? Here it goes. Let me tell you why. Does everybody agree that I have to multiply by 27 here? Which I'm going to say, yeah, this is what I'm saying. Yeah, you do have to multiply by 27, but don't multiply by 27 here. Don't get this huge number, 600, 700, I don't know, what numbers? Anybody multiply this? Whatever it is, don't multiply this yet, okay? Or you're not going to have to. Does everybody agree it's going to be 27 times 36 equals 8x? Yeah? And then divide what? By 8? Divide by 8. Why am I telling you not to multiply? Because x is going to be 27 times 36 divided by 8. But 8 can reduce with one of these. See, and if you multiply this and get this big number, you won't see it. 8 can reduce with which one? What? With 36. 8 can reduce with 36. Isn't it true that 4 goes into 8 and 4 goes into 36? Yeah. So it's going to be 4 goes into 8 2 times, 4 goes into 36 9 times. And then you kind of see if there's any more things that can cancel or reduce. It's nothing's going to happen. So whatever 27 times 9 is divided by 2, that's your answer. right? Because if not, you'll get that other answer, and then when you check it, it won't look like the same numbers, but it's just because it's not reduced. What's 27 times 9? It's got to be less than 300. 27 times 9, 243. Is that right? 27 times 9? Oh. Okay, there it is.